Hi, everyone. Welcome. I think I know half of the audience here, so please raise your hand if you already know me, because it's kind of like, OK, perfect. This is the perfect case scenario where you have a friendly audience with you, so please laugh with all my jokes and make very, very simple questions. So for those who don't know me, welcome. My name is Ignacio or Nacho. I am in the Google Play team, business development manager. I'm based in London, and I'm working with mobile game developers. So today we're going to talk about lifetime. So thanks a lot for coming, because I know there's very high competition, very tough competition, and very good sessions at this very same time. I think my colleagues are doing a great job. So the fact that you're here, I'll try to make the most out of this session. And the session is going to last for 25 minutes, and it's going to be recorded, so you can watch it later on. This is the agenda, and we're just going to cover some points. I don't have the answer to the lifetime value and the equation, and let's say that the million-dollar question, which is how we make money. But I hope that the session today will help you to kind of like understand this topic and hopefully take some decisions in the future, and it's useful for you. So the first question is like, why LTV and why everyone is talking about lifetime value? So I'm not going to spend too much time. I think we all know that these days everyone is talking about lifetime value for a couple of reasons. First, well, mostly the technology is enabling to track more things, and we kind of like track much more behaviors rather than just installs. We also see that in-game analytics, then it's becoming more relevant, and probably you have all data analysts within your team or your company. But also, like the whole ecosystem, that graph over there, we've seen it a number of times already, where revenues and usage are increasing, but install seems to be stagnating or at least stabilizing, which means that we need to make more out of our users, and then we need to think about other metrics. Maybe metrics that before they didn't have so much relevance, such as like long-term retention, day 90 or day 180, they become more relevant nowadays, and also lifetime value. So just to get on the same page, let's think about like what lifetime value it is, because I think we all agree that lifetime value is kind of like the expected revenues that our users are going to generate in the lifetime of the game. However, we do not agree in many other things. For example, the way to calculate lifetime value, nobody agrees. Everyone has their own custom way, and probably it's actually right. So that's one thing that we need to take into account when we are talking to someone about lifetime value. It might be very different from your calculation. A couple of other things. So for example, we have a crystal ball illustrating this slide, which means that we are predicting the future. And predicting the future means that we are not going to be accurate. This is not an accurate science. And therefore, we need to think about in terms of like, what is my error or interval of confidence, and therefore, what is going to be the range of my lifetime value. And then two last things, which would be dynamic metric. So my lifetime value changes over time. And this, we've seen it not only with external factors. Let's imagine that we have a competitor launching a similar game, and then all of a sudden my users fly. But also, like internally, we can affect this lifetime value by, I don't know, releasing new functionalities or new live ops, which are going to help to increase it, hopefully. And then last one is a metric. So it doesn't mean that by having a very high lifetime value, you're going to have a competitive advantage over the rest. And therefore, we need to think about, like, this is just a useful metric that is going to help us. So what are the usages? So the first, I think it's clear, right? If we understand the lifetime value, we can understand what are the costs, and therefore we can think about like what is our profitability for every user. And this is very much related to user acquisition, and it's been used most of the times in terms of like driving campaigns or UA campaigns, where we actually know how much are we going to spend, or at least what is our limit for expenditure in campaigns. However, two other ideas, which my conversations with developers, they haven't been used that much, would be to think about lifetime value also for live ops. So when we release a new functionality or new feature within the game, this might have an impact in engagement, but also in monetization. So sometimes we might see that the increase in engagement might offset the increase or by a decrease in monetization. So the net effect of that functionality is actually zero for lifetime value. So you can think about this way. Also for pipeline, thinking about like new games, if we start looking at this data from the very beginning and we have enough data, we can think about like a method or taking into consideration this metric by deciding a game. So once we have these, what I've done is to classify. I spoke, and I'm talking about popular ways here, because I spoke to many of you, actually, who are sitting here, and I want to thank at this point like, for participating in these interviews that I run for the last couple of months. And basically, I was asking like developers, we are working in a regular basis, what are the ways that they are calculating lifetime value? And what we're going to do is just like basically classify these ways, share some of these insights that you basically share with us, and try to figure out like which ways might be more relevant or more interesting for your actual game. So the first thing is like one common thing that we see in the lifetime value is that either we are talking about retention or like lifetime, a lifetime variable, or we are talking about a monetization variable in this case. But when it comes to lifetime, we again do not agree. Because if we think about retention, many of you might take retention as the classic retention, right? However, some developers, they were talking to me and they're saying like, well, in my game, it makes more sense to consider rolling retentions or range retentions because there are episodes and I'm launching a new season. Things like that, for example. Or daily versus hourly. Why in a casual game, it might not make sense actually to look at daily retention, but hourly retention because that's when we are losing the users very, very fast. Also collect daily rewards versus play a battle. As of today, retention is defined by opening the app. But what about like, there's a big difference between I'm opening the app just to collect a daily reward or actually playing a battle. The same stands for monetization. Most of the times it's ARPDAU, RPPU, or ARPU. But in this case also, how do you calculate the ARPDAU is going to make a difference. Am I taking the last week or the last 3 months? Because it might have a difference. So when I'm talking to developers and I'm asking them about like lifetime value, I'm going to have all these things into consideration. And it would be interesting for you to think before you're calculating it. Another common thing that most developers have is the period. And this is interesting because like, it depends a lot. It depends in a couple of metrics. How are we going to calculate the period, like the lifetime value? Is it going to be for 90, 180 days, 1 year, or even like 5 years? It might depend a lot in some key factors. So out of those conversations, we realized that things like, for example, type of the game, which makes sense. Like if it is a hardcore or casual, I might like look at longer lifetime values if it is a hardcore game. The business model that I'm using, the stage of the company, and it all comes down to the funding. So do I need to recover the investment in 90 days? Or do I need to recover it in maybe 365? So these things are also quite interesting because every company, they calculate it in a different way, depending on some of these aspects. There are more aspects, by the way, but these are the ones that I just wanted to highlight. So let's think about then how we classify all the ways that developers nowadays are estimating lifetime value. So I just put an axis there on the left axis, complexity, and then accuracy, because I'm assuming that the more complex you go, the more accurate you're going to be. That's a priori, because we can see that sometimes you can go as complex as you want, and the accuracy might not increase. But let's assume that the first one would be very simple, historical averages or benchmarks. That could be an easy way to estimate lifetime value. Then we will see simple predictive models, a little bit more advanced predictive models, and then, well, the super hyper advanced predictive models, I'm not going to cover them because they're usually involving like behavioral patterns. They are involving like specific things to the game. So if we look at the three first models, the first one is quite easy. And talking to you, we are not even looking at predictive. We're looking at our historical data, if we have the data, and maybe just assessing like the ARPU of the last 180 days, if my game has been released 6 months ago, was X amount. And I can basically estimate with a new user at day 3 is generating 70%, and then I will just project. And 100% would be at day 180. That's very simple, and to be honest, has some pros, which is like very easy to estimate. It has also some enables quick decisions at very early stages, but on the other hand, it's not very precise, and the averages might kind of like bias these results. By the way, if you don't have data, most of the developers, what they're doing then it's looking at like benchmarks or maybe similar games that you have in your portfolio, and then you say like, well, in my previous game, I was generating X amount. So what is the simple predictive? So when we talk about simple predictive models, we see two models which are quite used. The first one is the kind of like the top-down, because we are looking at all users, and then we are just going to estimate the lifetime value with this formula. You probably have seen it like in some places. And we are projecting the retention, which is the typical curve, survival curve. And then we look at like, well, at day 180 in this case, the retention is only 5%. So on average, 9 days per user are going to use my app. If I multiply this by the app DAO, then I can have, in this case, $0.45 would be the retention, the lifetime value expectation for this particular segment of users. A couple of pros, relatively easy to calculate. There's a number of spreadsheets online that you can download. And then the cons are, it's not very accurate again, because we're taking segments, and it depends, like from conversations that we have, the source of traffic might vary a lot, and might depend, the retention might change quite drastically. And then last one, ARPDAO usually improves with the life of the game, because my users more loyal, the ones that pay, they tend to stay longer. So my ARPDAO will improve. So let's look then at what about like, if I look only at paying users. This is the bottoms-up model, which is kind of like some model that also many developers are looking at, and it's basically projecting the RPPU, so the average revenue per paying users. In this case, we use a curve, which is a logarithmic one, and we can project very similar case that at day 3, I'm getting $30, sorry, 0.30, I wish $30, and 0.45 at the end of the period, which is day 180. A couple of pros in this case. So again, relatively easy to calculate. We have also that usually the percentage of conversions is relatively stable, and we can see that it's going to be like 1.5 or 2% of users paying. And the cons is usually this model, what I heard is that it works well when you have a game that most of the monetization comes up front. But some of the hardcore games or strategy games that you might have like longer monetization, or the monetization starts later, that curve might be difficult to fit. So let's move to the advanced predictive models. So what means advanced? Well, notice that the crystal ball is getting more sophisticated. We're using like historical data, and we are trying to predict individual lifetime value in a probabilistic way. So it has some pros and cons, in this case too. Oops. So the first one is obviously like we kind of like get an estimate at an individual level, which is very useful. It's usually more accurate. And the cons are we need extensive user data, and especially we need to have the resources and capabilities to interpret this data and execute based on these insights, which is very interesting. So, and why do we need like predictive models? Well, let me just illustrate with a very, very simple example. We have 2 users download the app. Both of them have sunglasses, but it's not related in any way. And they start like buying some gems. So you can see like Rick is a heavy buyer, and then Gavi, it is like a more constant but less purchases. So if we look at certain models, or if we look at the past, we can think that Rick at this stage, if we look forward to 180 days, would be more valuable than Gavi. However, many of these probabilistic models tell us that indeed Gavi is more likely to make a purchase. And okay, you might not like, why is that and how is that? How do we do that? Well, I'm not going to like talk about any model in particular, but I'm going to talk about one model in particular. I'm not going to recommend it because I'm not getting any it's an open source model, but this is one model that we are actually looking here at Google many times. It's called the BTYD model. It's open source. It's backed by academia and by some Wharton researchers. It's based on these 2 models, which is the Pareto NVD and the BGNVD model. And I recommend you to have a look, because it's quite simple, and it might help you in this if you're thinking about like a predictive model. So it's based on 2 submodels. One is actually looking at the likelihood of making a transaction, and the other one would be looking at the value, like what is going to be the future average order value of those transactions. So just to illustrate how it works, I'm going to use the same example. So we have Rick Rick bought a lot of times, and the likelihood of making a transaction is based on two variables, which is recency. So we are assuming that the most recent that you did a transaction is the more likely that you're going to make another one, and then the frequency, which is like how many times did you buy. So we are assuming basically that a user that buys a lot during a long period of time is going to be more likely that he's going to buy again. So Rick bought a lot, but only like in the first 5 days, which means that then he's probably very, like you can see the colors, and he's in the dark, dark blue, which means like very likely he's not going to buy again. However, if we look at Gabby, she bought very, very little, and then we can see that in this case, like the likelihood of buying, and this is, again, this is a model that is done based on research and empirically also, we can see that she's also buying, she's going to be more likely to buy. So what can we get out of these type of models? So most of the times, we get like first the probability of being alive. So at a certain point of time, looking forward, we can see like, okay, this user is going to buy again or not. So the number of transactions that this person is going to make, this user, the expected average order value, so how much is going to spend, and finally, the expected user LTV, which is, in the end, is the product of all the other things. So just taking this model as an example, what would be the pros and the cons? So first, the pros, again, we have individual lifetime value, which is interesting. It's open source. You can download the Python APK, the package, and you can start by today. And it's backed by academia and empirically, and also can be used for other purposes. I think this is interesting because some people are saying, well, you're only taking purchases, but we can think about also some events. Like, for example, I don't know, like level 1, you could even consider that and estimate the likelihood of playing other levels. On the cons, what do we find? Well, as I said before, it works within our purchases as today. If we think about advertising, it would be a little bit more challenging because of the number of events that this is registering and requires significant amount of data. Okay, so this would be the model. So which one is the best? So again, it's quite hard because every model has its pros and cons. I would say that personally, I would try to look at predictive models whenever it's possible. There's many of them. The one that I explained is just one of them, but there's others that could be useful. And I'll try to look at these whenever we have these other key points into consideration. So what is the current situation of the game? Have we launched it a while ago and we have the data? What is the primary business model that we're looking? The type of game? And finally, if we have this information about individual lifetime value, can we do actually something with it? We're just going to let it there, and we actually do not have resources because we need to do something else, right? So is that all? Well, actually, when talking about lifetime value, there's other things that people are considering, developers. So most of it, at first, is most of the developers, they are looking at net LTV and profitability rather than gross LTV, so they are already subtracting some of the costs. Then the second one is you're looking at very long-term lifetime values, like 180 days farther or beyond. You might think about like maybe looking at discounting it. Then business models, many of you are using two business models at the same time, in-app purchases and advertising. So one good way is think about like how would you integrate both of them, and you would look at all your users from both business models at the same time. And then lastly, we see a general trend in the mobile gaming industry, a lot of multiplayer online games that might need indeed to assign some monetary value to those users that they generate some liquidity. You don't want to find yourself playing against a bot again and again and again over. If you think about other things, so virality has a very, very important function in UA, but it a priori doesn't affect the lifetime value because you're augmenting the equity of players, and I'm putting that example over there, but it shouldn't affect the overall lifetime value because you're just adding new users, the equity of those paying users. It still is very important from a UA perspective because you're bringing another user with that user that you acquire. And then last two things would be frequency of calculation. So how frequent are you calculating? I wouldn't recommend daily, but I would say like depending on the game, if you're constantly updating, so think about this. And then lastly, the segments and the cohort analysis. The first one would be top versus lowest spenders. This is a typical one.
Some developers are looking at geographies, obviously, and then traffic sources. Those would be the most typical ones, but there might be others that you are currently overlooking. So with this, so what are the tips and best practices? So there's some tips to improve. I asked many of the developers, what would you do like to improve the LTV calculation, right? So the first one is forget about like vanity metrics that they are not used in the end. I put downloads, but sometimes or registered users, we might argue this, but in the end, like you want to care only about like those metrics that are relevant for an LTV calculation. In this case, for example, active users, cost of new customers, revenues and profit. The plan thoroughly, it's super important to like try to plan in advance rather than just going reactive and trying to maybe delete events that they are not used in your daily decisions. Integrity of data, super important. We need to think about how we have integrity, like data that is real from the very first day. And then lastly is making trade-offs. So if we don't have enough data to actually take a decision, we might have to think about how we extract those whales or those users that might, heavy spenders that might bias my sample. So conclusion, if you reach to here, like 5 things that I want to remember, like 5 is a lot, but yeah. So the first one is like LTV has many usages. As of today, it's very much used for UA, but you can think about also from a live ops perspective to decide whether a new functionality or feature is going to be useful. Then we can think about also that it's not an accurate science. So think about when you're talking about lifetime value, think about like a range or like an interval of confidence. Lastly, if you can, the predictive models might be useful if you have the data and you have the capabilities. Again, I'm not saying that don't use the other ones, but just think about this in case you can actually run them. And then fifth point would be decide in advance what are the things that the cores, the frequency, how frequent are you going to calculate LTV, and finally, make sure that you track the relevant metrics, and then you basically have things like integrity of data and take the decision based on relevant samples.